Okay, so let's proceed with the next discussion. And these are the advanced techniques of integration. So as what we have agreed by the other EM teachers, especially with the EM coordinator, your tentative schedule for the midterm exam will be on the 25th of March. That would be Saturday from 1:30 to 4:30 p.m. So it may be from 1 to 4 or 1:30 to 4:30. So depending on the final schedule that we have um, to agree prior to the exam. So again, that would be March 24, Saturday from 1:30 to 4:30. So since we are 2 weeks from the exam, I think it's 26th day. 26, I think it's 26, okay, 25 would be on the Friday. So 26th day. So what we're going to do is we're going to discuss one topic each meeting. So we'll discuss algebraic substitution today. Then on Wednesday, we have to discuss trigonometric substitution, integration by parts by next Monday, and then lastly on Wednesday, integration by partial fractions. So the coverage for the exam has been reduced to this topic only, the final techniques of integration. So the definite integral is not included anymore in the exam, so it will be included in the final exam na. So just try to check your syllabus. So everything that is definite integral is not included. So what we have discussed is only included in the exam. So up until integration by partial fraction only. So from start up until this topic. Okay. So let's proceed to the first advanced technique, which is algebraic substitution. So before we proceed, so these advanced techniques are used in um, complicated functions. So for example, those functions which we cannot solve using basic basic format of integration. So for example, you're given the different formats katong mga formulas. So for example, it cannot be solved using by simple U sub or by simple case 1, type A, type B, type C, etc. So if you cannot solve those ones using the basic method, so we're going to use advanced techniques of integrations, which are the four presented on your screen. So to start off, we're going to discuss first the algebraic substitution technique. So in algebraic substitution, so we have to evaluate the integral by introducing a new variable of integration in place of the original variable. So the underlined phrase here looks like the step or the process of the U sub technique. So actually it's just like the U sub technique, but we have to do some additional process in the substitution technique sa kaning particular technique kaning particular process. Okay? So of course inspection is done in the integrand, same as U sub. And there are no general rules, and it only requires practice for you to be able to appreciate this method. So actually, one rule lang siguro ani para nako. So instead of there are no general rules, so probably my one rule here is you have to replace the radical expressions. Wrong spelling on expressions. Okay? So what do you mean by radical expressions? Kana mga nth root of something or x to the power of any fraction of variable, di ba? Those are still radical expressions expressed in exponential form lang, di ba? So mga inana na mga terms. So probably what you're going to replace here is those terms. So for example, if you see equations having those terms, so automatic algebraic substitution na. But of course, it's not 100% that you have to use algebraic substitution. There are also terms that even though it's expressed in radical expression, it can still be solved by a simple U-sub technique or katong simple U-sub na process. Okay? So take note that radical expressions, we're going to only be using algebraic functions, algebraic terms. So there may be some examples wherein you're going to use trigonometric functions, but simple trigonometric functions ra inyohang makitaan inside the radical expression. So you may also use this particular technique, but again, only sa mga simple na trigo functions, not the complicated versions. So for example, what's inside here is just sine x, ana? So pwede ra siya gamiton. Okay? So for us to be able to appreciate what I am talking about here, so we have to solve 7 examples. So notice that in each examples, we have radical expressions present in the examples. So for example, in number 1, we have square root of x, square root, number 2, square root of x, number 3, square root of x minus 4, number 5 is, number 4 rather, fifth root of x plus 1 squared, and then we have cube root of x plus 1, cube root of x squared plus 4, square root of x, cube root of x. So notice each examples have radical expressions. So again, if you see radical expressions, automatically use algebraic substitution. But of course, take note that you have to observe the given integrand first if it's solvable by a simple U sub or not. So for example, in number 1, so let's try. So let u be 1 plus x, diba? Then du is equal to dx. So you can replace this as u, you can replace this as du, but how about square root of x? So wala, diba? So it cannot be solved by a simple u sub. Or if mo try po jud lain, square root of x, diba? So du is equal to 1 half x to the power of negative 1 half dx. So again, there's no negative x to the power of negative 1 half. So meaning you cannot solve this one using simple u sub. So ana lang siguro akong tip ninyo. So just try to, so if you try to observe some radical expressions, try to observe first if it can be solved using simple u sub. If not, go directly to algebraic substitution. Okay, so let's try example number 1 first. So in u sub, you are using u, diba? But in algebraic substitution, instead of using u, so even though it's still a substitution technique, so we're going to express it as another variable. So, so another variable, because probably in the process of answering the equation, probably in somewhere in between the process, you have to use u sub, di ba? So para dili magbalik-balik ang atong variables, so sige lang tag u, di ba? So basin maglibog niya mo later on if we are going to use u variable all throughout the substitution method. So here we're going to use z parameter or z variable. So let z be the radical expression. So z equals square root of x. So again, the aim here is to eliminate the radical expression. So we have to square this equation for us to eliminate the radical expression. So this becomes z squared equals x. Okay. And then the next step is we have to derive. So the same as u sub, after getting the z or the x parameter, we're going to get its derivative. So this becomes 2z dz equals dx. All right, so I think we are done. So why do I say that it's done? Because this term here is now the z term. So meaning everything can be replaced in the equation. Dx is this term here, 2z dz. And then the x variable on the denominator is expressed as z squared. So, diba, you can now change every variable in the equation. So of course, we can just ignore 1 because it's a constant, diba? You cannot replace it with the variable unless the variable is ang variable na i-replace is kaning binomial. Let's say z is equal to x plus 1. So ma-change ang 1, diba? But here is we are just changing the variables because 1 was not present in the process or in the calculation. So the equation becomes, so square root of x is now z, and then dx is 2z dz all over 1 plus z squared. So we have 2 in the numerator, so we can just take it outside the equation. So it becomes 2 z squared all over 1 plus z squared dz. So of course we cannot just cancel out the z squared, diba? Because it's not correct. Binomial man siya, diba? So if it's isolated terms, z squared over z squared, so you may cancel out the z squared. But since this one is one whole term, z squared, against one whole term, 1 plus z squared, so you cannot just simply cancel out the z squared. Kay kuyog man ang 1 sa inyong z squared sa denominator. So what do you need to do here is, of course, if you go back to your basics in algebra, so if the numerator and denominator has the same, or if the numerator is of greater degree or equal degree in the denominator, so squared, diba? Squared, and then squared. So you may use long division for you to simplify this equation. Sorry. Okay, so long division. So let's try to solve this one separately. So divisor, 1 plus z squared, and then dividend is your z squared. That's the numerator. So you have 1 here because 1 times z squared is z squared plus 1. And then again, minus, diba? Ato nakatunan sa long division sa atong elementary and high school days. So 0, and then this becomes negative 1. So the answer is 1. So that's the quotient. Then how do you write the remainder? So that would be minus the remainder, 1, all over the divisor, 1 plus z squared. So that's how you write it. So meaning your equation becomes so 2 integral of, so instead of this term here, it now becomes 1 minus 1 over 1 plus z squared dz. So expanding further, so we can have two different integral symbols. So the purpose of which is para lang makita na ko basta niya ang other term is complicated. So if you can see that the terms inside are integrable easily, dali siya ma-integrate. So you can just integrate directly. But if you have some confusion or some verification that you need to do, so just try to separate it for you to avoid confusion. So 2 integral dz minus 2 integral of 1 over 1 plus z squared dz. So in the first integral, so we can say that it's easily integrated, diba? Integral of dz is just z. So how about the second integral? How do you integrate 1 over 1 plus z squared? So of course, this is just a simple formula again. So if you try to recall the discussion sa katong mga formulas, so this expression here is an inverse function, di ba? So notice that it's similar to du all over a squared plus u squared, which gives us the arctangent function, inverse trigonometric function. Okay, so next is you have equals 2z minus 2 arctangent z. So again, I didn't write 1 over a anymore because a squared is 1 and then a is 1 gyapon, diba? So it would be redundant if you're going to still put 1 over 1, diba? And then z plus c. So this is not yet the final answer. We still have to bring back the value of z. So the final answer would be 2 square root of x minus 2 arctangent square root of x plus c. And then this would be the final answer. Okay. So probably what we did here was just a simple kuan lang. So the same lang siguro siya sa USAB, but again, we are more focused on eliminating the radical expression. So step one, declaring the z variable sa radical expression, then eliminating, then deriving, and the rest is, I think you can just follow through here, diba? Okay, so questions for example number 1. Okay, so silence means no siguro. Okay, so we go on to the next example. So next example is we have here the integral of dx all over x minus square root of x. So again, we try to observe the radical expression. So this is what we're going to replace with a z parameter. So again, upon observation, we cannot use simple u sub, diba? So this one becomes z equals square root of x. And then getting the square, so I'm not going to write the square anymore. So this becomes z squared equals x. And then getting the derivative, this becomes 2z dz is equal to dx. Okay. So again, as we notice, we can now replace it with every term now in the equation. This becomes z, x becomes z squared, dx becomes 2z dz. So the equation now is 2z dz in the numerator, replacing dx. X is now z squared minus square root of x, that is z. So next is we simplify equations. I mean the terms inside the integral symbol or the integrand. So factoring out 2, then this becomes z dz all over. So we can factor out z so that we can try to eliminate it or cancel it out in the numerator. So z minus 1. Okay, so cancel out z, and this gives us 2 integral of dz all over z minus 1. So of course the answer for this one is the ln, the du over u. So if you want to verify it, just try to use u sub, diba? So this is the time that you're going to appreciate the other variable z, diba? Diba? So what I have said earlier, there are some process or steps that you're going to use u sub nasad. So for example, in this manner, u is equal to z minus 1, then getting the derivative, du is equal to dz. So this will give you 2 integral of du all over u. And this will give you 2 ln of u plus c. So bring back the value of the u parameter to ln z minus 1. And then the final answer, as you bring back again the value of the z variable to ln square root of x minus 1 plus c. So that's the final answer. All right, questions or clarifications for example number 2? Okay, so I think there's none. So let's move on with example number 3. So again, replace the square root with the z parameter. So square root of x minus 4, and then getting the square of both sides, z squared is equal to x minus 4. So probably we're going to have an extra step here since we have an x variable here. So we try to isolate x. So this becomes x equals z squared plus 4. So muna siyang gamit niya later on. Then getting the derivative is we got 2z squared, 2z rather. So 2z ni siya. So 2z dz equals dx. So same na siya og answer ah. So whether you are deriving this one or whether you are deriving this one, it gives you the same answer. So it's still 2z dz equals dx. Okay? So now if you're going to observe the equation again, so the x variable here will be replaced by z squared plus 4. The square root of x minus 4 will be replaced by z. And then dx will be replaced by 2z dz. So creating the new equation, this gives us z squared plus 4 cube, and then times z times 2z dz. Okay? So what we need to do here is we're going to expand the binomial to the power of 3, then multiply it by z and 2z dz. Okay? So para dito maglibog, let's try to simplify it as much as we can. So before expanding, let's try to get the constant outside. Then this becomes z squared plus 4 cubed. Then multiply z here, so it's z squared and then dz yan ala siguro. Okay? So before multiplying everything by z squared, so we have to expand this one first. this one. So if you forgot the formula for this to the power of 3, so try to recall Pascal's triangle. So if you don't want to recall Pascal's triangle, so you have to manually expand this two at a time, diba? So z squared plus 4 times z squared plus 4 sa una. The next is z squared plus 4. Nasa, imo sa i-multiply sa z squared plus 4. Meaning katulo ka mag-multiply og z squared plus 4. But if you know the shortcut, so just try to recall Pascal's triangle. So ano naman, diba? 1, 1, then 1, 2, 1. So this is the quadratic equation or the second degree, diba? Second degree. The next is the third degree. So dili third degree Berna, but third degree polynomial. Okay? So as you might recall, the quadratic equation, if it's 1 to 1, so for example, you have this one as a plus b squared, it gives you a squared plus 2ab plus b squared. So muna siya 1 ang coefficient, 2, and then 1, di ba? 1, 2, 1. Now if it's third degree, so that this would be a plus b cube. So this would give us a cube plus 3 a squared b plus 3ab squared plus b to the power of 3. So muna siya shortcut, di ba? Para di kayo mo maglisod. So muna siya murag if you appreciate the previous discussion sa inyong mga high school and senior high, so magamit kaya po siya karon. Okay, so this gives us 2 integral of, so by shortcut, this gives us z to the power of 6. So squared and cubed, di ba? Power rule, power to power, you multiply it, 2 times 3, that would be 6. Plus, so ab, so a squared, so c squared squared, this would give us z to the power 4. But for the coefficient, that would be 3 times 4 pa dyan, di ba? So this would give us 12. 12z to the power of 4. The next is 3ab squared. 3ab squared. So a is just z squared. But for the coefficient, 4 squared is 16 times 3. This would give us 48 z squared. And lastly is b cubed. 4 cubed, that would be 64. And then times z squared dz. So multiplying z squared to further expand the equation, this would give us z to the power of 8 plus 12z to the power of 6 plus 48z to the power of 4 plus 64z squared, and then dz. All right. So looking at the expression inside the parenthesis, so you may just multiply this or you may just integrate this manually, diba? Katong basic formula. So don't forget to multiply 2 to each term once you integrate the different items inside the parenthesis. So the first one is 2 times z to the power of 9 over 9 plus 24. So 2 times 12 is 24. Z to the power of 7 all over 7. So 2 times 48, that would be 96. 96. Z to the power of 5 all over 5 plus 128. 128 z cubed all over 3 plus c. So this one is not yet the final answer. We still have to replace it with the z parameter. So the final answer would be, so in case of this one, square root, then na may exponent dire. So just try to write it in fractional nga exponent para di kayo maglibog. So this one is 1/2, di ba? X minus 4 to the power of 1/2. So multiplied by 9, multiplied by 2, multiplied by 7, 5, and 3, and so on. So na may better view sa inyo ang final answer. So this would be 2, and then x minus 4 raised to 9 halves all over 9 plus 24 times x minus 4, 7 halves all over 7, and plus 96 x minus 4, 5 halves all over 5, and then lastly is 128 x minus 4 raised to 3 halves all over 3 plus c. So muna siya inyong final answer. All right. So do you have questions for example number 3? So I guess there's none. So let's proceed with example number 4. Okay, so if you're already comfortable with solving this one, so kung kita ka directly o radical expression, so you may just write it directly and c fifth root of x plus 1 squared, di ba? So probably you might get confused on how to deal with this one. So just try to express it in its exponential format. So x plus 1, then raised to 2 fifths. Then multiplying everything by 5 over 2 to eliminate the fraction exponent. Okay, so this becomes z to the power of 5 halves equals x plus 1. So again, we have an x variable here. So try to isolate x first. X equals z to the power of 5 halves minus 1. So next is to derive. So we're going to have z, or rather 5 halves first, z to the power of 3 halves equals dx. Okay, so kani siya, derivative na siya. Bring down the exponent, 5 halves. Then 5 halves minus 1 is 3 halves. So dapat paspas na mo add and subtract fractions. Okay, usually the complicated equations are those having fractions as exponents. Or probably just simple fraction. Okay, pinapag-divide, di ba? Kaya magsige na siya reciprocal na. So just try to master fractions. Okay, so if we try to observe again, so x here is going to be this item here, z to the 5 halves minus 1. Fifth root of x plus 1 squared will become the z parameter. And then dx will become 5 halves z to the power of 3 halves. So of course, during the exam, so don't try to circle stuff and then butang mag araw-araw, di ba? Okay, kani ako is just for the sake of discussion for you to be guided with where the variables are coming from. So of course, dapat in the exam, kibahan na mo sa detailed process and without the lines na, di ba? So kani ako is just for the sake of discussion. Okay, so we now have so x being z to the power of 5 halves minus 1, and then times z being the fifth root of x plus 1 squared, and then dx is 5 halves z to the power of 3 halves dz. So napa na siya dz dito. I forgot the dz. Okay, so taking out the 5 halves, since it's constant, so 5 halves integral of z to the power of 5 halves minus 1 times z, and then times z to the power of 3 halves dz. So take note that this one is z to the power of 1. So if you try to multiply this one with each of the term in the first term sa binomial ninyo, then this one in the second term, so this would give us 5 halves integral of, so 5 halves plus 1 plus 3 halves, that would give us 10 over 2. So this is z to the power of 5. Then this would give us z to the power of 5 halves dz. So basi na-shock mo ano na siya. So just try to figure out what I did here. So I just added the exponents. So 5 halves plus 1 plus 3 halves is 10 over 2. So 10 divided by 2 is 5. Negative 1 times z to the power of 3 halves, that would be negative z to the 5 halves of 5 over 2, because 1 plus 3 halves is 5 halves, di ba? So this time we can now integrate. So don't forget to multiply 5 halves. So this would give us 5 halves times z to the power of 6 all over 6 minus 5 halves times z to the power of, so plus 1, this would give us 7 over 2 all over 7 over 2 plus c. So the final answer would be 5 over 12 z to the power of 6, and then minus 5 over 7 z to the power of 7 halves plus c. So nawala ang 2 because cancel out, diba? Reciprocal of 7 halves is 2 over 7. Okay, so bring back the value of the z parameter. So again, for you not to be confused, try to recreate it as this format kani siya. Exponential format sa iyong radical expression. Exponential expression rather. So 5 over 12, and then this would become x plus 1. So 12 fifths na siya, di ba? Minus 5 over 7, and then x plus 1. Then this would give us 14 over 2. Over 5 mo din, no? Over 5. Sayap ni over 5. 7 fifths man din eh. sakto ba itong gibuhat? Sakto dahil, sakto. Wait sa... Uh, this one is 5 na din eh. 7 halves, and then 7 halves, and then times. So this would be 14 over 10 din siya. Okay, 7 halves man siya. Plus C. So 7 over 10, this would give us a simplified version of 7 fifths, diba? So 5 over 12 x plus 1, 12 over 5 minus 5 over 7 times x plus 1. So since everything is divisible by 2, so 7 fifths plus C. So this would be your final answer. All right? All right, questions or clarifications? Okay, so I guess there's none. So basin ipanggutom na siguro mo, no? Okay, so let's proceed with the next example. So again, automatic radical expression expressed as z. So cube root of x plus 1. So getting the cube, this becomes z cubed. Then this becomes x plus 1. So again, just try to isolate x so that you can see if you can still replace any x in the equation. So this time not a x variable, so we have to isolate x. X cubed minus 1. So getting the derivative, we have 3z squared dz is equal to dx. So pabalik-balik na ang kuan, di ba, ang inyong button. So x here is going towards this portion here. Dx is now 3z squared dz, and then 3 cube root of x plus 1 is now your z. So this would give us z cubed minus 1. Then dx would be 3z squared dz. And then denominator would be z parameter. So simplifying, cancel out z, cancel out z. So we have still one z here. Then factoring out 3, constant. 3 integral of z cubed minus 1. Then times z dz. Okay? So next is we expand it further. 3 integral of z to the power of 4 minus z and then dz. So this can be integrated easily. So what we now have is 3z to the power of 5 all over 5 minus 3z squared over 2 plus c. So again, bring back the value of the u parameter. So again, for you not to be confused on how to deal with exponents and the radical expression, so just try to make it as exponential expression. So x plus 1 raised to the 1/3. Diba? So with this, you can just multiply 1/3 with 5 and then 2. So the final answer would be 3 times x plus 1 raised to 5/3 all over 5, then minus 3 times x plus 1 raised to 2/3 all over 2 plus c. So mura na siya. So any questions or clarifications for example number 5? Okay, question? Wala ra? Sige, sige. Okay, example number 6. So z is equal to cube root of x squared plus 4. And then getting the cube of both sides. So cube root and cube are two different terms. Cube is to the power of 3. Cube root is cube root ka ng radical expression. So x squared plus 4. So if you try to isolate x here, you're going to have x squared equals z cubed minus 4. So notice that the given number here is x cubed, diba? So we'll try to figure that one later once we are done deriving the z parameter. So this gives us 3z squared dz. Then you're going to have 2x dx. So notice we have x dx here. So we can probably just create this one as x squared times x, diba? Times dx, so that one can be expressed as x squared, and the other will be expressed as x dx, diba? So for you to be able to follow, let's try to track it down. So this term here is now the z parameter. So instead of x cubed, we have to get portions of x cubed and create it as x squared times x dx. So x squared becomes x cubed minus 4, and then x dx. So let's try to continue lang gamay. So instead of, so this one is 3 halves z squared dz is equal to x dx. Para siyang naon dyan. Okay, so we are now given z cubed minus 4. Then x dx is 3 halves z squared dz. And then our denominator is just z parameter. So cancel out one z. Then taking the exponent outside, we now have 3 halves integral of z cubed minus 4 times z dz. So 3 halves, so expanding further by multiplying with z towards the binomial. So we have z to the power 4 minus 4z dz. So you can now integrate easily. So 3 halves times z to the power of 5 over 5 minus, so 3 halves times 4, that would be 6, diba? So 6 z squared over 2 plus c. So simplifying, we now have 3 over 10 z to the power of 5 minus 3 z squared plus c. So 6 over 2 is 3. So again, para di mo confuse, so try to write this one in exponential form. X squared plus 4 raised to the power of 1/3. So 1/3 times 5 and then times 2 pa dyan, di ba? So 3 over 10 times x squared plus 4 raised to 5/3 minus 3x squared plus 4 raised to 2/3. Ano siya? And then plus c. All right. So questions for this example? Okay, so hearing none. So let's proceed with the last example. So para at least we can now start with your assignment. So magdunga-dunga mo din yung deadline sa assignment, no? So hopefully nahuman to yung first two maskin nagkuhan mo sa inyong CE days. Okay, so this time is we have two different radical expressions. One is squared, one is square root, the other one is cube root. So I think that I think it's difficult for us to replace one at a time, di ba? Kaya, for example, if you're going to let z equals square root, so you can't replace the cube root, di ba? Or if you're going to let z as cube root, you cannot replace the square root also. Okay, lain-lain mas lang radical expressions. So one technique here is that for you to be able to simultaneously substitute your z parameter is that for you to declare it as one variable. So how do we do that is first we're going to get the LCD of the radical expression. So how do we do that is again this one is x raised to the power of 1/2. Diba? This one is x raised to the power of 1/3. So so technique here is we just multiply the numerator, I mean the exponent. So this would give us x to the power of 1/6. So why do we do this in this particular example? So later on you'll be able to appreciate that once we use 1/6, we can eliminate both the square root of x and the cube root of x at the same time. So probably what akong suggestion nyo dire is for you to be able to understand this one, dapat magdungan og eliminate ang duha ka radical expressions. And we need just one z or one z variable to do that for us to be able to eliminate both radical expressions. So shortcut is just get the LCD of 1/2 and 1/3. You have 1/6. And this will be our z parameter. Z is equal to x to the power of 1/6 or the sixth root of x. So multiplying by power of 6. So this becomes z to the power of 6. This becomes x. Getting the derivative, 6z to the power of 5 dz is equal to dx. Okay, so once you're able to do that, so try to observe what happens with the two radical expressions in the denominator. Okay, so square root of x, square root of x. This is z to the power of 6 plus cube root of z to the power of 6. And then dx is 6z to the power of 5 dz. So notice that square root of z6, you can have the square root of z6 as, so let's try to remove 6 out at the outside of the integral symbol. The numerator is now z to the power of 5 dz. So again, 6 root of z to the power, square root of z to the power of 6 is z cubed, and then square root of cube root of z to the power of 6 is z squared. So notice that na eliminate dungan ang inyong radical expressions, di ba? Because we express it as one variable or another variable which can eliminate both radicals at the same time. So ana ra siya pag inyong the way how muna siya inyong way of understanding this problem. Okay, so simplifying the denominator, so we can factor out z squared. So z to the power of 5 dz all over z squared plus so z squared, so say so this will give us z squared and then z plus 1. So cancel out z squared, this one becomes 3. So what is left now is 6 integral of z cubed dz all over z plus 1. So again, take note that if the numerator has a higher degree compared with the denominator, so you may use long division. So long division, this is z plus 1 and then divided by z cubed. So dapat kibaw mo long division na. Okay, basta niya di mo kabaw sa mo chudog ako, di ba? So I'm just showing you how the process works of the long division. So minus z squared, or rather zira minus z squared minus z, and then take the minus sign, di ba? So z na lang, and then plus 1. So you have negative 1. So the equation becomes 6 integral of z squared minus z plus 1 minus 1 over z plus 1 dz. So since there's no more space in the screen, so just try to continue this one on your own. So probably if you try to integrate this one, this would give us 2z cubed, sakto man siguro ni, plus, or rather minus 3z squared over 6, and then plus 6z, and then minus 6 ln z plus 1 plus c. So try to verify that one, and then of course don't forget to bring back the value of the z parameter in your final answer. Okay, so questions or clarifications for the last example? Okay, so having none, hearing none. Sige. Kuan, basta Basta wala na variable sa pinaka-last sa remainder, diha mo stop. Okay, for example, kanina, negative 1, wala naman siya variable, then you have a variable sa divisor. So you cannot multiply 1 na jud kay magbalik-balik inyo ang variable, di ba? So if it's constant na inyong remainder, so stop na mo diya. Sige, sige. So any further questions? Okay, so if there's no question, so I think this is it for this session. So see you all on Wednesday for our next topic. So thank you very much.